Hello everyone, today I'll show you how you can build yourself a custom wall generator that you can add doors and windows to any mesh that you have. For example, I have this mesh from Quixel Megascans of a wall without any mesh and windows, and I generated a wall with a single window and a wall with two windows. As you can see, you can place the windows where you want, you can have as many as you want. I have another example here with a door and a scaled window, so you can see that you can scale to reposition every element. You can even scale and reposition your wall element, so you can modify the pivot with this generator and cool stuff like this. So after you finish generation of your mesh, it will output a single static mesh that you can use in your PCG scripts to generate a building. So let's start with checking how the generation works, the finished version that I have prepared for testing this. So let's go here and add this wall generator. It will use this mesh by default, but you can replace the mesh with any mesh you have. Let's start with this wall, for example, to have something different. So you walled the mesh for the wall, then you can add a mesh for the door. Let's use this one. Let's reposition it because it's coming in a different angle, but you can see that it's starting to cut the shape of the door into the wall. So let's just reposition this door. We'll rotate it, move it, and we'll scale a bit the bounding box that we use to cut out this shape. For example, like this. Let's move it a little bit out. Okay, something like this will work. It's not using the proper material, that's why it's looking a little bit strange right now. But when we replace the materials, it should work fine. So for example, let's say this is the final mesh you want. Let's click on the save mesh, and you need to specify a path and a name for your mesh, otherwise you will have an error. Save name and path cannot be empty. Let's save it here into this Megascans folder. So let's copy this path and let's call it test5. Let's save this mesh, and now you can see you have this finished mesh. Let's add a material slot for the door, and let's connect the proper material. And when you save this mesh, you can see that now I have this mesh in my content browser and I can use it anywhere, like a normal static mesh coming from any pack or any custom mesh that you created. So let's start by seeing how you can create this generator. It will help you to make custom buildings with all the elements you want, not just the available in the packs from Quixel, for example. So let's go into this tutorial folder. Let's start with creating the blueprint actor that you will place in the level to generate the wall. So right click into your content browser, create a blueprint class, choose for the parent class actor in order to be able to place the blueprint in your level. Call it bp underscore wall underscore gen, for example. Then we need to create a PCG component, PCG graph, sorry. So write in the search PCG and choose the PCG graph. If you don't have this listed here, make sure that you have the plugins loaded. So click on the Edit, Plugins, and type Procedural here. You will need the Procedural Content Generation Framework and the Procedural Content Generation Framework geometry script interop, because you use the new geometry script compatibility with the PCG graph to generate new meshes from your PCG with the input meshes that you provide. After you mark these two checkboxes, then you'll restart the engine and you'll have everything needed for this project. So again, right click, type PCG in the search and choose the PCG graph. Call it PCG_wall_gen. Let's open the blueprint that we just created. Now here, let's create a PCG component. So write PCG and choose this PCG component. Into the component on the right side in the details panel, you have this graph field. You need to drag your PCG graph here in order to connect it to the PCG component in your blueprint. So compile and save. Open this graph now. And here let's do a test node that we can see that everything is working with the connection between our blueprint and our PCG graph. So let's drag our blueprint in the level here. Let's choose our PCG graph and let's, for example, do a create points node. We will do a single point at the 0 coordinates, and these coordinates will not be our level 0 coordinates, but our local component. So we will create it here where we place the blueprint component into our level. So save this, mark this create points node. Let's click the D key for debug. We don't see the point here. Let's choose the absolute method here in order to have the proper scale shown. And now you can see that we are creating the points into our blueprint. So everything looks fine. We can continue with the adding nodes into our blueprint and we'll see the different changes into our level. Let's start first with creating the mesh for our wall. So let's first go into our blueprint. Let's create a couple of variables here. Let me make this window bigger so it's easier to see. So okay, for the variables, let's create a new variable, call it wall mesh. This will be of type static mesh. And choose a static mesh object reference. Let's make it public in order to be able to be used into our PCG graph. And let's do one transform node so we can move, rotate, or scale our wall. So let's call it wall transform and choose for the type transform. Make it public again. And let's do one other variable called save mesh, for example. Let's do this as a boolean. And we'll use this field when we click on it if we have set up a path and a name to save our mesh into our content browser, so we can reuse it as a static mesh anywhere into our level. So for example, let's add these two fields, mesh path, which will be of a type string, and then another one, mesh name, again of type string. Let's make all these variables public, compile and save the blueprint. And now if we go into our PCG wall generation graph, let's start with creating our logic inside here. First, get the actor property. So right click and get actor property, and for the name, call it wall mesh. This name should exactly match the variable that you created here, this wall mesh variable. So you can right click and rename this and copy the name, or click F2. This will enter into the rename mode, so you can copy this, or you can copy it from the details panel variable name field. So make sure that this property name into your PCG graph is exactly the same as the one of the variable, otherwise you will have an error here. For example, if I put a space here, you will see that I have an error that this property doesn't exist. So if I have the name correctly, it will work. Sometimes if you have not created this variable as a public variable, you will have the error here, and it will not disappear into this actor property, even if you have after this make it as a public property. So just create another get actor property and enter again the name here, and it will work fine. Wall mesh. Okay, now to use the new features that are using the geometry scripting, we need to convert our static mesh to a dynamic mesh. We can only apply our geometry scripting onto dynamic meshes. So right click here and choose static mesh to dynamic mesh element. This is a new node in 5.5. So if you're using an older version, this tutorial will not work at all. So make sure you're on Unreal Engine 5.5 or newer. So open the node so you can connect your wall mesh into this static mesh field. So after this node, when you convert it to a dynamic mesh, let's then do a dynamic mesh transform. So do a dynamic mesh transform. Again, open the node and you can add the transform here. So right click here, get actor property again. This actor property will be wall transform, and connect it to the transform here. So now if I debug this node here, the one with the transform, let's save this PCG graph. Let's minimize this for now. And if I put some wall into my wall mesh, you can see it's appearing into my level where I have placed my blueprint. Let's open our PCG graph. Let's show both the graph and the level. So now this is showing the debug mesh for my PCG graph. If I hit the D key again, you can see I have nothing in my level. The D key shows the debug mesh, the generated result of this node, but it's not actually spawning anything into my level. To make the PCG graph spawn an object into your level, you should drag out of this node here and spawn dynamic mesh. So this will spawn any dynamic mesh that you have created previously from your graph. So let's click the D key here to remove the debug node for this. And now you can see we are spawning a dynamic mesh into our level. We are not looking at the debug now, it's spawning a dynamic mesh right inside our level. So let's out click on this connection. You'll see if I don't have the connection to the spawn dynamic mesh, I'm not spawning anything into my level. So let's spawn the mesh, and now let's go back into our level here. Let's mark our blueprint actor. And here into our wall transform, we can start changing these values to see that we are able to move the wall the way we want because of the connection of our dynamic mesh to the dynamic mesh transform. Let's add 100 units here, for example, and you can see it's moving the wall into the direction that we want. And let's say, for example, you want to make the pivot point of this wall to be in the middle of the wall, because by default it's coming like this. So you can see that it's placed at the edge of the wall, and for some reason when you generate objects in your game with the PCG graph, you need it to be in the middle. So you can use this generator that we are creating now, and let's write here -200. And if I specify a mesh path the same as we have now, so copy the path from your content browser without the O field, let's add a line at the end, and for the mesh name, let's call it test wall 1. Now, if we click this save mesh button, nothing happens, nothing is created. This is because we haven't connected any of these properties to our PCG graph. So let's go back here into our PCG graph. From our spawn dynamic mesh, let's do a save dynamic mesh to asset. This will open this save dialog, because when you connect this save dynamic mesh to asset, it's using the default settings. Here on the top you can see this open save dialog is marked by default. So let's cancel and let's remove this open save dialog. So now this save dynamic mesh to asset doesn't know the path and the name of the asset that it should use. So we need to take them from here. So our mesh path and mesh name variable from our blueprint. So let's go back to the PCG graph. Again, get actor property. Let's choose the save path. I have the name different. So mesh path, okay. This should be mesh path. Let's connect this to the asset path. Let's copy this and change it to mesh name. And let's connect this to the asset name. So now I should be able to see this new object created into our content browser. And you can see it's created with the pivot point at the center because we moved the original object 200 units to the left. So this is the original one, where the pivot point is at the left, and this is our modified one with the pivot point in the middle. Okay, let's continue with our generation script. So what I like to do for this save dynamic mesh to asset, as you saw, I have added into my blueprint a Boolean value in order to be able to choose when to save this. So only when I'm ready to save the asset, I want this to be saving into my project. Otherwise, on any change of your PCG graph, it will save a new version of this object, and it will make your development really hard because it will pause for a second to generate a mesh, and if you have not finished your changes, it may cause some error, and this may crash your engine. So let's do a branch node here. So drag out of here, do a branch. The output B is where we can output if we connect a Boolean value here. When the Boolean value is true, it will output to the B branch here. So let's click on this connection to remove it. Let's connect this to the B branch. So we want to output to our B branch here and use this save dynamic mesh to asset only when we have marked this variable save mesh into our blueprint. So right click, get actor property. The name should be this save mesh, and connect this to output to B. So let's save here. And now let's minimize this. Let's go back into our level. I have my generator selected. I have this save mesh marked. So let's uncheck this. And let's do some change here. Let's make it actually to be easier to see. Let's move it up. If I click this save mesh, it will save this change to our test wall 1. So let's click save. If I drag it, you can see it's moved up. If I unclick this save, let's move it back down. It's not saved here because I don't have this checkbox set to true. That's why it's not saving my changes. So this is the best way to leave it when you're working unchecked, and only when you have finished your creation of the wall, just then click this save mesh once and it will save to these values. If you don't have anything written in these values, for example, the mesh name is empty, and now if I click this save mesh, let's, for example, make it rotate 30 units. So we can see here if we are changing it. Let's click the save mesh. You can see nothing is happening. This is because we don't have any mesh name connected here. So let's make sure into our graph that we are checking if our mesh path and mesh name are entered, so we are able to save our asset properly. So let's go back into our PCG graph. Let's do another branch node here. So if we click the Save Mesh button, we want to check if our mesh name and mesh path, let's copy them. Let's create attribute. This attribute will be of type string. It will be just an empty string. So let's check if this mesh name is not equal. Let's choose this attribute compare operation, not equal. If this mesh name is not equal to an empty string, and this mesh path is not equal, so not equal to this empty string, and both of these conditions need to be true, so let's do an AND Boolean operator. Make sure you're not using this bitwise, but the Boolean operator. Let's connect both of them here, and let's open this branch node here. Only if these conditions are met, let's output to B and connect this to the save dynamic mesh to AST. If these conditions are not true, so we have any of these values not entered, let's drag out of this output A and do a print string. Let's make the string list the error here on the screen. For example, enter mesh path and name. Let's change the verbosity to warning. And let's click here on print on screen. Let's save this. And if we go back to our level, we have this mesh name not filled in. So if we click on the save mesh, you can see now into the top of the screen, enter mesh path and name. If we enter the name test wall, let's say we'll enter 2 now to be different, it will create this new mesh into our level. Okay, now that we have this setup, let's continue with the generation of our wall to make it be able to add a door to the wall or a window. So let's go back into our PCG graph. I'll remove these 2 walls that we generated here. Let's go back to the PCG graph. And now, after we transform our mesh. So we reposition the wall the way we want. Then the next step will be to add a mesh for the door, for example, and do a Boolean operation on the wall to cut a hole for the door, and then do another Boolean operation to merge the door with the wall. In order to do this, let's check. Let's check first with example mesh. For example, create a dynamic mesh. So static mesh to dynamic mesh element again, like we had before. And for the static mesh, let's choose a cube. Let's write cube here, and let's choose this one, static mesh cube. It's a default cube from the engine, so you should have it. When we spawn our wall into the level, when we create the dynamic mesh for our wall, let's after this create this static mesh to dynamic mesh element for the cube. So we are creating dynamic mesh for the cube, and then let's do a Boolean operation. The operation will be of a type subtract, and we'll subtract from the wall our cube. Let's connect this to our spawn dynamic mesh, disconnect the old connection, and now you can see we are starting to cut away from our wall where our cube is placed. Let's reposition a bit everything so it's easier to see for you. If I mark this static mesh to dynamic mesh element and click the D key, you'll see this cube is placed here. And this is why when we do a Boolean operation of subtract, it's cutting away this part of the wall here. If we use a dynamic mesh transform here, dynamic mesh transform for our cube, let's disconnect this and connect it like this. Let's transform the cube, for example, 100 units into X, then minus 50 in Y, and you see it starts to create a hole into our wall. Okay, now we have this fill into our hole that we don't want when we are creating windows. So for this Boolean operation node, let's open this options here into the details panel, and let's uncheck fill holes. And now you will see that we have a proper Boolean operation leaving a hole into our wall. So how you can do this with the custom mesh and not with this cube that we used, for example. So you can see that if you try to use some window mesh, so let's choose this, for example, this window that I downloaded from Quixel. Let's show it into our level after the transform. Where is it? It's too far back. So let's move it a bit to the front. Minus 10, 0, minus 5, 5. You can see we are not cutting into the wall. The problem is that this window is not a single shape that we can extract from the wall. It's filled with holes, and its geometry is not really suited best to cut into other objects. We need a simple cube that can be extracted from this wall, and it will leave us with the hole in the wall. So this static mesh to dynamic mesh element, we need to change with a couple of nodes in order to create this box that we will use to cut into the wall instead of this complicated mesh that we have. So how you can do this? First of all, this static mesh to dynamic mesh element, let's not use just a fixed mesh like now. So clear this and let's get the actor property and let's create a property for our wall. So let's go back to the blueprint. Let's create some other variables here. So for our wall generation, let's add a variable, call it window mesh. This should be of a type static mesh. Let's choose static mesh object reference. Then let's create window points. This should be of a type PCG point. And it should be an array. So right click onto the PCG point field or go into the details panel and here instead of single choose array. So we have multiple PCG points because we can have more than one window. Let's compile and save this. Let's make this public values. So now if we go back to our PCG wall generator, let's get the actor property with the name window mesh. I have a warning, so like I told you before, if this property doesn't exist when you create this node, it will continue to give you the warning even if you write it correctly. So remove this get actor property and create a new one, get actor property, add the name window mesh, and now the warning is gone. So let's connect this to the static mesh field for this static mesh to dynamic mesh element. And if we go back to the level, if we debug, okay, we have some problem. So let's disconnect this node here and let's start debugging the nodes. We are generating the wall into this static mesh to dynamic mesh element. Let's stop debugging it. We are transforming the wall. This static mesh to dynamic mesh element is not generating our window mesh. The problem is that we don't have the window mesh connected to our blueprint. So let's go back into the level. If we select our blueprint wall generation, and if we connect this window mesh here, now we can see that debug is showing our window mesh properly. Okay, now this works fine. So in order not to have this problem, if you don't have a mesh connected into your window mesh property, you don't want the whole script for this wall generation to stop working. So you know how to fix this by the save path example before. Do a branch here. Let's compare this window mesh property with not equal. Let's compare with a new attribute. So create attribute. It should be of a type string. It will be an empty value. So if we have an empty value for our window mesh, we'll output to B here. So the empty value will be B. So let's do it the other way. Let's not be a not equal. Let's do a equal. So if our actually not equal was fine. Sorry. If our window mesh is not equal to an empty path. So in other words, if we have a window mesh, we want to do this Boolean operation. If we don't have a window mesh, we just want this to continue and spawn only the wall. If it goes through path B, so we have a mesh, then we want to spawn the mesh after this Boolean operation. Instead of this dynamic mesh transform, we'll use the points from our blueprint that we created. So remember, we created these window points. Let's do it plural because we can have more than one. So Windows points. We have this array of PCG points. So let's get an actor property. this property. Let's set the name to Windows points. Let's go back to the blueprint actually, and let's add a default value for this. Here into the bottom of the details panel, you have the default value. So let's add at least 1 point. So you don't have to enter manually a point every time. If you connected a window mesh to your PCG graph, you will have at least 1 point by default with one window. You can add more. Now let's use this. For some reason, you can not directly convert this into points. So the workaround here is to create a copy attribute, and the attribute we will copy. We need to connect this both to the source and the target, and we will copy the transform from our window to the actual point transform. What I mean by this, let's mark this getActor property, click the A key to show the attributes, and if you mark the PCG wall generator that it's in your level, you can see we have this transform position X, Y, and Z, the same for rotation and the scale as properties here. And let's do like this, transform points. So you cannot connect directly these points to these nodes that's requiring points. So first let's do a attribute set to points. So write attribute set to points, connect this attribute set here, and connect this to the transform points. So now let me show you the problem here. If I click the A key here onto these transform points, you will see that I have additional values, transform position X, Y, and Z, but they are not used here into the actual position of the points X, Y, and Z. So this is why I'm using these copy attributes. Let's actually do it after this conversion. Let's disconnect this and now connect it like this. So I'm converting this attribute set to points. Then I will copy from transform, and this should be position. I have warning, input does not have transform attribute. So click A again here. Let's right click here and copy the attribute name to be sure that we are doing it correctly. Let's remove the point X. Okay, now it's fine. I have some error in my spelling. So now we are copying the position from the point to the point attribute from the actual point position that we are generating in the script. We need to do the same for the scale and for the rotation in order to change the properties of our window. So let's do a copy attribute again. Let's choose here transform dot scale, and for the output target, let's do $scale. And now the last one, copy attribute. This will be actually transform dot rotation, and the output will be $rotation. Now if I connect it here, this should be source and target for all of them. We have the variable for our points connected, and we are generating the points into our PCG graph, and we want to create mesh that we want to subtract from our wall, so the bounding box of this window, in order to cut it out from the wall mesh that we have. So we need to copy this bounding box shape onto all of the places that these points are generating. So to do this, we need to do a custom blueprint PCG node, because there is not one currently available. At least I don't know for it. Do a custom node, drag out this execute blueprint node here, and let's choose some node, for example, this attribute operations. Doesn't really matter, but click this browse to async content browser button, and this will browse to the folder in your engine plugins folders, and you need to not be in this deprecated folder, but go into the BP elements folder. These are the newest ones. So let's, for example, use this distance to density node. We'll copy this and we'll copy it into our tutorial folder where we are creating our PCG graph and blueprint. Drag this distance to density node into our folder. Choose the copy here option. And here I have now this distance to density. Let's change the name to copy dynamic mesh dynamic bounding box, for example. Copy dynamic BB. Let's open this. If we open now this functions PCG folder, you have 3 functions here created. It will be easier to use this already created one. That's why we copied it from the engine folder. Go into the last one of these functions, node title override. This is the title that it will show into your blueprint. So copy bounding box, for example. Compile and save this. And if we go to our PCG graph, let's drag out this execute blueprint here and choose copy dynamic bounding box. This copy dynamic mesh is the function that I created earlier when I was testing how to create this script. So don't be fooled that this already exists into the engine. We'll create it now. So copy dynamic bounding box. And this is the name that we added here into the override for the name. Copy bounding box. So let's save this. Let's go back here. Let's click on the Quas Defaults button. And here in the inputs and outputs field into the details panel, we have currently set up one input and one output. Let's change the type from point to dynamic mesh for the input and dynamic mesh for the output. Both the input and output will be a dynamic mesh, and we'll add another input which will be of a type point. We'll allow multiple data. Let's not allow multiple connections. And let's add a label of points, for example. Compile and save. And if we go back to our PCG graph for the creation of the wall generator, you can see that this node now has 2 pins. One of them is for a dynamic mesh. So the dynamic mesh that we will use is our window mesh. So let's connect it here. Connect the result of this node to our boolean. And the points that we will use are the points that we generating here. Let's remove these transform points and connect the points directly that we are adding into our blueprint variable. So inside this copy bounding box function, if we go to the execute with context function here, you have the function that we copied from the engine content. And what we'll use from it is everything until this for each loop. And after this for each loop, we'll delete everything. So after this for each loop, let's break our PCG tagged data. Let's cast this to PCG dynamic mesh data because our input is of a type dynamic mesh. Then after we cast it to this type, let's construct a dynamic mesh data. Let's right click here and construct class, construct object from class. And the class, let's choose PCG dynamic mesh data. So we will construct an empty dynamic mesh by this. Let's create a variable. So we deleted a bunch of stuff here. So let's click now the edit button and then delete unused variables. We still have a lot of variables that we don't need left. Let's check where we are using them. Let's open the point loop body function. We have a lot of stuff here, so let's delete everything except the start of the function and the return node. Let's connect the in point to the out point. Let's uncheck this return value for now. Compile and save this. And now if we go to edit, delete unused variables, we have a lot more unused. So now we have emptied all of the variables that we had from the copied blueprint, and let's create our own. Let's do a new one called dynamic mesh data. Let's call it original. The type will be PCG dynamic mesh data. Let's create another one, mesh data final. We'll save the beginning of our dynamic mesh here, and after we create the box, we'll set it here. And if we have multiple boxes, we'll set all of them into this final data. That's why I called it this way. So next, let's create another variable, call it size. Let's make it public, and the type will be vector. You'll see why we'll need it later, but for now, let's create it that way. Go back to the execute with context. So now we are creating an empty mesh data. Let's connect it here. Save this into our original data. Let's append box to this. This will be our bounding box representation. So from this dynamic mesh data, inside this there is a dynamic mesh element. So drag out of this return value, choose the dynamic mesh and connect it here to the append box target mesh. So we'll append a box inside the data, dynamic mesh data that we are constructing here. It will be empty, and after this we'll have a box. The size of the box is right now 100 units. But here, when we are breaking the actual data that comes from the connection into our PCG graph here we have a dynamic mesh, that's our window. So here, if I get the dynamic mesh, this is our window mesh. We'll get the mesh bounds, get mesh bounding box. And from this bounding box, we'll do a little bit of math. So let's split this bounding box. Let's use the max and subtract the min. That's how we will get the size of the box. Let's do another subtract here. And what we'll subtract here is this size variable that we created. I'll show you how we can use it. And now let's split this pin and connect the X, Y, and Z values here. So we'll create a box with the sizes of the bounding box of our window. So compile and save this. In order to create the actual object from this, we will need to initialize this dynamic mesh. So drag out this dynamic mesh, choose the initialize method, and the target mesh from this append box, put it inside this in mesh. Then we'll construct another empty data. Construct object from class. The class again will be PCG dynamic mesh data. This is the one that will put multiple boxes depending on how much windows that we have. We'll make this our final data. Let's connect it like we had it before. Let's get the dynamic mesh here. And let's initialize actually this mesh.final. With this mesh. So this will create the mesh that will start to populate all the boxes inside. So here, where we are getting the first input, which is our dynamic mesh, into our PCG graph, after this toArray node, we are getting the first input by this get0. If you remember, into our class defaults, we created two inputs, and the first one with an index 0 is our dynamic mesh. That's why we are getting here the dynamic mesh as a result of this get inputs by pin label. And the second one we created with the index of 1 is our points input. So let's drag out of here and get the next one, so the one with an index 1, and do the same like on top. So copy this inputs by pin label and for each loop, and the pin label will be this. Let's move all of this after the dynamic mesh that we created here. Let's make sure that we have a little bit better routing for our graph here. So we are getting the next input, which is our points. And for each of these points, let's break this stacked data again and cast now to PCG spatial data, because these are the points that we are sending to this custom blueprint. So with this PCG spatial data, we'll call the point loop function. This context, right click here, and we have a variable context. If you scroll at the end, write context, scroll at the end, and you have already created variable context. Connect it to the context here. This is by default coming from the function that we copied. Let's copy this context here and do to actually here from the spatial data, 2-point data with context, and connect the context here, the in data, into the point whoop. Compile and save this. We have an error. Okay, here I need to connect the collection as well. So just like we did here where we copied this pin label, let's drag out of this connection and connect this collection here. So compile and save, and now it's saved fine. So the last thing that is left to do here is to create our point whoop. So the last function here from the element that we copied is this point whoop. So inside this point whoop function, what we will do is for each point, let's disconnect everything for now. So for each point, we'll break this point, we'll get the transform, and we'll append a transformed mesh to our final dynamic mesh. So let's drag out this final dynamic mesh, get the dynamic mesh element from it, append mesh transformed, and the mesh that we'll append is our original mesh, which is the bounding box from our window mesh. Get the dynamic mesh from this data, plug it into the append mesh, and then plug the transform into the append transforms here. Let's connect this to the return node and the in point connect to the out points. Compile and save. So for each point that we are creating, we will be appending a box in the place that we want this window based on the transforms of this point. So let's save everything. And if we go back, let's minimize this. Let's go back into our scene here. Let's open our generation to check if everything is working fine. So right now, let's preview our wall here. So we are creating this wall. We are transforming it. Currently, no transform are applied, so it's on the same place. Then, if we have a window mesh connected, so let's make sure that our blueprint here has a window mesh connected. It has one. We are creating this window mesh. We are transforming it. Currently, we don't need this transform. I was using it to demonstrate with the cube how we are placing a hole in the wall, but let's delete this. Okay. Now, this is the mesh that we are creating. And now let's debug this copy bounding box. It seems that it's not returning anything. So let's go back to this copy dynamic bounding box and let's go back to the execute with context. If we go back here, right now, we need to make a little bit of changes here. So instead of returning this out tag data, we'll control drag this mesh data final. This is where we are generating all the bounding boxes for all the points that we are passing to this blueprint. So let's make PCG tagged data from this, and let's connect this to the PCG data collection. Let's delete this. Okay. So now, after our for loop, which is going to execute for all the dynamic meshes, then our other for loop for all the points that we have on the completed path here, we are returning all of the dynamic boxes that we create. So compile and save this. And now I can see that I have a huge box created here by this node, and it is actually cutting into the wall. The problem is that it's a lot more big than our box, and it's not on the place that we are placing our box. The place is modified because we have a transform entity here. We also have a scale. That's the problem. Okay, so now if I have the scale set to 1, let's change the location, 100, 100. You can see I'm properly creating a box and cutting inside the wall. It's not cutting through the full wall. So let me go back to this copy dynamic bounding box function that we created right now. Let's go into the graph here where we connected this size value. So this size value, we currently have the default values of 0, 0, 0. What this does is based on the bounding box size here, it's modifying each of the sides. So for the first value here, if I put a number, it's making the box thinner and thinner. This is, for example, if you have a mesh that has some boards of the window are sticking to the sides and you don't want to cut the full bounding box shape, but only the center part where you don't have some shape sticking out to the end, you can use this value to cut a little bit less than the full size of the bounding box. Same for the height. You can use this to scale it. And for the thickness of the window, you can use this middle field. And this is quite useful in this case because we want to make this box bigger and cut through the full wall. So this will accept negative values to make it bigger. So write minus 50, for example. Okay, minus 100 will do a full cutout in this wall for your window. And that's great. Let's test by compiling and saving this. And let's add another point into the Windows points here. Hit the plus sign. And for the second one, let's add a transform 100. Here, let's put 200, 250. You can see we are now generating 2 boxes and we are cutting both of them through the wall. Let's go back to the PCG graph. And the additional step here, let's make this a little bit smaller so you can see everything. So when we are cutting inside the wall, the next thing that we want to do is to place the window in the hole that we created for it. So for all of these points here, let's move everything here a little bit to the right. So every point that we create, we need to append mesh from points. So the dynamic mesh that we want to create, let's do a create empty dynamic mesh. We will have an empty mesh and we'll append to all of these points our window mesh. So get actor property, and this property should be our window mesh. Let's open this node and connect this to the static mesh. Let's debug this, and you can see that it's copying the windows at the places that we want to cut inside the wall. So this is not finalizing our creation here. We need to do another Boolean operation. So Boolean operation. This time it will be union. And for now, let's connect it directly. I'll show you that you need to do one additional step later, but for now, let's do it like this. So now you have the final mesh as the wall with the two windows that we placed manually by choosing the points that we want them. And we have the final mesh generated. Let's go here into the level and click on the save mesh. It should be saved inside our folder for the wall. So this is our wall. Let's open this inside our details view here. The problem is that currently you have only one material slot, and you have a wall and a window inside that needs another material connected. So in order to fix this, we need to create another custom function, which after creating the last one, this one will be really easy. So how to do this? Again, let's choose the BP elements folder that we had. This distance to density, for example, let's copy it inside our folder like we did before. Let's rename it to copy material ID. Go inside this blueprint and do the same like we did before. Open all the functions here. The node title will be copy material ID. The point loop body will not need anything from this, so delete everything. Connect it like this, compile and save, and into the execute with context, delete everything here after the for each loop, compile and save, and into the class defaults, open input and output, and change the type to both of them to dynamic mesh. Let's compile and save. Let's actually not allow multiple connections into both the input and output. So for the material ID, we'll start with the similar break PCG tag data, then cast to PCG dynamic mesh data. This dynamic mesh data, let's remap material IDs. Let's again click the edit button, delete unused variables. It will delete everything. Create a new variable, call it to material ID. Let's choose an integer type, make it public, compile and save this. And let's connect this to the remap material IDs, copy from 0 to this new material ID. Then we want to construct object from class. The class will be PCG dynamic data, dynamic mesh data. Let's promote this to local variable. Let's call it mesh data. And let's initialize this. The in mesh that we want to initialize this with is this target mesh here. So we'll create a mesh with the copied material ID from the 0 to 1, and we'll save it into this mesh data. And at the end of our loop, instead of this, let's delete this alt tag data. We'll use this mesh data, make PCG tagged data, and connect it again to here. Let's compile and save this. To this copy material ID function, let's go back into our PCG wall generation. Let's drag this execute blueprint node and choose the material ID, copy material ID. Now I have two because they are the same name, sorry. Let's rename this to be sure, copy material ID tutorial. This is the one I created now. Let's choose this copy material ID tutorial. Let's connect the in. My editor crashed. Okay, now that I have my editor reloaded, let's go back and check if we have some problem into the copy material ID function. Okay, this is the function that we created. So we start the point loop, we are breaking the data, we are casting to the dynamic mesh type. Okay, here we need to actually connect the target mesh that we want to remap the IDs for. So get the dynamic mesh from our input and copy the material IDs to the provided ID. Let's try now. Let's open the wall generation PCG graph and let's execute our blueprint. Let's get our copy material ID function. Let's save everything to be sure if the engine crashes again. Let's connect this and then this, and now we don't have this problem anymore. Now you can see that we are placing a wall, then a window, and we are cutting this into the wall. Our values again are a little bit big for our window points. Let's choose the point and reduce the size and move it inside the wall, for example like this. Now if we click the save mesh, we have the path to be the folder of our wall, which is this one. Let's write the name test wall 3 and click the save mesh button. Actually the path is this one. Okay, we have now this test wall 3. Let's open it, and inside this, now if we add another material slot, if we isolate the first and the second one, okay, everything is again on the first slot. This is because here where we copy to the material ID, we need to provide the ID that we want to copy the material to. So let's create attribute. Let's make this an integer value and the value will be 1. We want to copy the material for the window into the slot 1. So now, because I have this save still enabled, so it's resaving my asset every time that I change something. So let's uncheck it because it already saved it, and you can see it already has two different materials. So if I go back to the model here, if I add another material SWOT, I can add the material for my window. So let's type window here. And let's choose this old wooden window material. Let's save this. And now if I'm back to my level, I can use this newly created static mesh everywhere I want, and you can choose your generator. Let's type another name, test wall 4. Let's add another window, so another element here. Let's choose the transform, let's scale it, let's move it. For example, like this, just to show you that it will create additional object. So if we click the save mesh, now I have this newly created mesh. The only thing I need is to create the other SWOT and assign the proper material. Save this. And now you saw that I'm generating different type of static meshes with the properties I want. The only thing that you're missing from the demo that I showed you earlier is the adding additional mesh for the door. So to do this, to be really easy, just go inside your wall generation. Here you will need another variable for the door mesh, another one for the door points. The door mesh will be of a type static mesh, and the door points will be of type PCG point. It will be an array. Compile and save, make this public, door mesh and door points. Let's open our PCG generation graph. And let's move everything here to the end. So for the windows, we are getting the mesh, checking if it's valid, so it's not an empty string. We are then copying the points attributes to the actual points position, rotation, and scale. Then we are copying the bounding box, cutting inside the wall, and then applying the mesh with a union. So let's mark everything we created here. Let's copy it. Let's paste it here. Let's connect both these paths to this branch here for the wall, for the door. And let's change the property names. This for door mesh. This will be door points. There's a problem. There's no door points variable. Let's check how we called it. Door points. It's not public. Okay, compile and save. Like I told you, create new, get actor property. Door points. Now we don't have error. We don't have a default value for this. That's why we are getting these warnings and this error here on the bounding box. So let's go back here. Let's add a default value for the door points. Compile and save this too. And now this should again be the door mesh. And the ID that we want to copy the material will be 2. Now everything will connect to the create dynamic mesh, spawn dynamic mesh, sorry. Save this. We still have an error here. Let's connect everything again. And okay, maybe the problem is that we don't have a door connected. Let's go here and connect our door mesh. Okay, now everything seems to work fine. If we choose our actual generator here, everything is working fine, no warning, no errors. So let's save everything. And now let's test this by moving the door with the door points transform. Let's do a -2 in Z. Let's move it 300 units here. Let's actually remove the windows for now, at least the first window, it's in the middle where we have the door. Okay, so here is where this size property that we created can be used, because our model for the door, let's put it here with the proper material, has this sticking out parts at the end. So the bounding box is actually bigger than the hole that we want to cut inside the wall. So inside our blueprint, we need to create two other variables, which will be window cutout, for example. It will be a vector type, and then the door cutout. Both should be public, compile and save. And here, inside our copy bounding box functions, first is for the windows. So let's get actor property, window cutout. There's an error. Let's copy the name to be sure that it's the same. Okay. Connect it to this size value for our copy bounding box blueprint. And do the same for our door cutout variable here. So here, create bounding box, get actor property, paste the name and connect it to the size. Now if you save this, save everything. If we go back here, we have this door cutout value that we can use to set how much we can cut inside the wall to fit our door. Let's do here -100. It seems fine like this. Let's reposition the door. This is the window, sorry. Door points. Okay, something like this. And for the window cutout, again, we'll need a bigger value to cut through the whole wall. We have a little bit of a gap between the window and the wall. So we need to move the window. Let's do -10. So you can bring the window inside the wall like this, or you can extend it outside with, for example, -2, like this. You can do whatever you want by generating this asset for your level. So when we generate this, it will be saved automatically again in the same folder as you specified in the path variable. The only thing you need to do right now is when you open the asset, just to create the material slots and drag the material for the door into the third slot and for the window into the second slot. And now, when you save this asset, you can use this everywhere in your level. So I hope this helps you understand how you can use the geometry scripting with the PCG graphs inside the Unreal Engine 5.5. If you have any questions, please ask in the comments. If you like this video, please like and subscribe because it will help me a lot to continue to create these tutorials. And if you want to watch the videos earlier, please join the channel. We have different levels and different perks, but if you want to support me, this is the best way. So guys, I hope this helped you a lot and I'll see you in the next tutorial. Bye.